Go.
Good evening, everyone. A very warm welcome. In today's session, we will be discovering mathematics through art for the preparatory stage. The session would be taken by Mrs. Ishita Mukherjee. Ms. Mukherjee, postgraduate in mathematics, B.Ed, has been teaching mathematics since 1991. She is a master trainer for CBSE and conducts capacity building workshops for teachers all over India. She is also a resource person for Faculty Development and Research Center, FDRC, Shankar Vihar. Ishita Mukherjee is a co-author of the newly introduced book, Mathematical Literacy, brought out by CBSE. She's a CBSE committed member and contributor to the art integration towards experiential learning and innovative teaching methods for joyful learning in mathematics for CBSE. It's a pleasure to have you with us, dear ma'am. A warm welcome to you. Would request you to take the session forward.
Thank you, Preeti, and welcome everybody. So it's a start of a new session. I hope if you could mention it in the chat box, whether the screen is visible to all of you. So we
Yes, ma'am.
are
The
going
screen is
to
visible.
discover mathematics through art. So we are going to talk about what is the connection between the two. And as we do that, I take you through the first one is a quiz, or rather a question I'd like you all to answer. Please have a good look at the slide which is coming up now. Keep your fingers ready. Now here are 4 slides. I want all of you to have a good look at it. And in the chat box, can you just mention what all similarities do you find in them? Just write any word. Don't bother about punctuations and spellings and all that. Okay, I see somebody has written shapes. Great. What else? Just write whatever. Okay, I can see geometrical shape, triangles, patterns. So these things you find are similar, right? There are 4 of them there. How many of you think that there's an innate similarity between some rays? Lovely. Okay. There's an innate, do you find an innate similarity between the 4 of them? Parallel lines. Lot of, see, I don't even have to say that, there is mathematics in it. You people are tessellation, rhythmic movement, all right, rectangular shape. There you go. All right. So I don't have to define what is the connection between art and mathematics. You've already found it. But the best part is this. Do you see that they are from 4 different continents? The first one is an African. They are all tribal arts, okay, which means it's kind of ancient. It belongs to the people over generation. The first one is African art, which is the continent, African continent. Then you have Greek art, European. You have Maori art, New Zealand, so that Australasia, and lastly Hawaiian, which is American. So you can see that how they are related, and this is even before globalization. As I said, that these are folk arts, tribal arts. So would I be correct in saying this? How many of you would agree with me that mathematics knows no geographic boundaries? In mathematics, the cultural world is one country. Would you agree with me in this? Okay. I can see answer coming up. True. What about the others? Or you can ponder on it and think about it, whether it is
So,
true or
ma'am,
not.
we are also getting replies from Facebook. All of them
Okay.
seem to agree with you.
All right, that's nice. Yeah. So here we are all, globals in mathematics, we are global citizens. So let's see what is mathematics and culture, what exactly they are two and why they come together. All right. So, what is mathematics? It is a study of numbers, shapes, and patterns. Now, here I would like to, stress a bit. Everybody knows it's a, study of numbers, yes. But what a lot of people forget are the shapes and patterns, and they are extremely important. It is the science that deals with the logic of shape, quantity, and arrangement. Actually, numbers, which is arithmetic, that is one of the part of mathematics. They are not synonyms. Okay, does anybody think that mathematics and arithmetic are synonymous, that they are one and the same thing? Would anybody like to, has any kind of doubts about that? That arithmetic and mathematics, the words are synonymous.
So let me also look for answers on Facebook, because Facebook, it takes a few seconds to transmit,
Yeah, there's a
and
bit of
this,
time
yeah,
lag.
yeah,
Yeah,
yeah, there's
yeah.
a bit of time lag.
So, and also sometimes, you need a little bit of time to think. But anyway, as we go on from here, that
So someone says this is Preeti ma'am and also Lalit ma'am. They say no, they aren't synonymous. While Archana ma'am says yes, it is synonymous. Uh,
okay. All right, but we have a so I would go with the no this thing, because arithmetic, it is mathematics, but it is a part of mathematics. If I were to speak in completely mathematical language, that if I say mathematics is the universal set, then it's a small basket, it's a subset of mathematics. Mathematics consists of arithmetic, algebra, geometry, calculus, trigonometry. It's a whole lot of things. And arithmetic actually is the simplest of them all, because it has exactly 4 operations, which gets over by class 4th or 5th. Okay, but what continues is logic. You cannot have mathematics without logic. Logic of what? Shape, quantity, arrangement. So it's all around us. And what is culture? Culture is the characteristic of knowledge of particular group of people, which encompasses language, cuisine, social habits, music, and arts. All right. And already we found this connection between mathematics and art. So that is why mathematics actually becomes a global culture. 2 plus 2 is 4 everywhere. There is no difference anywhere in the world about that. So let's see what are the various kind of arts. Now, because why I'm going into this, a lot of people feel that when we talk about art, it is only about visual art. No, there are various kinds of art. You can see on the screen, there's theater, there's dance, there's music, and of course, there's visual art. So today, like, of course, I'm going to spend a bit more time, well, quite a lot of time actually, on visual arts, because it's easier, and the situation that we are going through during pandemic times, that is the most accessible. But I'll talk a little about role plays also. Now comes the question that why have art integration? I'm not going to go very deeply into it, because I'm sure by now all of you know it's not only about mathematics, it's about all the subjects. So you would realize that it's an approach which, students can demonstrate understanding through an art form. Now here, this is what is very important, and a lot of people make mistakes about, teachers as well as teachers. Please understand, it says construct and demonstrate understanding through an art form. Now, what I see happening a lot of times, that people are basically beautifying their stuff, making art around their notebooks or question paper, and putting in a lot of colors, which really don't add value to it. So therefore, that is not what exactly art integration is, and we are going to discuss that a lot today, where students are engaged in a creative process which connects art form and other subject area. What are the benefits? It's there on the screen, so I'm not going to read it out for you. It's just that, the learning experience becomes more active, the matter becomes more comprehensible when it is something visual, whether it may be visual art or dance or anything. Your all other senses are also involved, and you have a deepening and personalizing of the learning experience. We talk about experiential learning. And lastly, which I find very important, that firstly, students enjoy participating in these activities, and it is irrespective of their abilities. That is that, when we go on to our slides, as teachers, I would really like you all to judge that whatever slides that I put up, are those things accessible, which means easy to do for children or not? Because if they are not accessible to students, then there's really no point. So I'll just quickly put out the objectives of the session. That is to, use participants, familiarize them with the certain things like number patterns, how in art forms, through art forms, we can do this, number patterns, geometry, mensuration, fraction, decimals, and percentages, constructions. And lastly, I would also take up a question, or based on that, any word problem which you can do a role play on. So here you see some number patterns. If you look at this is something which is not only visually pleasing, it can, also aid in, or in fact, let me put the question. If you were to show this, use this kind of making patterns for young children, all right, what all ways can you use it? Anybody? Fastest fingers. Just type in whatever. Don't use long sentences. It's really difficult to type in. What do you think where you can use it? You tell me. I would like you to think. Instead of just teaching 1, 2, 3, 4 or something, where do you think this kind of thing people might find interesting? I mean, more attractive. Anybody?
So some teachers on Facebook.
Numbers, square, cube, that means shapes like we can see pentagon, hexagon. Great. All right. Games. Tell me, how about addition? Like if you look at the first one, as you can see, they are square numbers. All right. So if you see it is 1 plus, 4 more, that is 5. And then 4 more, then that is, you have 5 plus 4, and then 4 more, and so on and so forth. So do you think we can have an addition instead of asking a child to add 1 plus 4 plus 9 plus something? We can ask them by write down the dots in these and then count the dots. Do you think children would enjoy it? What do you feel? Standing, sleeping, slanting lines, yes, of course. So do you see that these kind of number patterns you can see around, and things they can relate to them, and also they can, make, in fact, you can even ask them, all right, can you make patterns? Just imagine you ask a child to make patterns of numbers, represent them. So the first one is a dot, like you might have seen Pascal's triangle. The second line has 2 dots, and the third line has 3 dots, so on. In fact, that could be given as a worksheet. 1 dot, write what is the number. 2 dots, like recognizing numbers. Do you think that would be a useful thing for, a primary teacher of class 1 or so? Would children enjoy it? Enjoy doing that? Because, that is somewhere the child can,
Yes, they will
also
enjoy.
show creativity, right?
Lots of teachers on Facebook say they will enjoy. Yes, the students will
Yeah,
enjoy.
okay, great. So moving on. Now, one thing also I wanted to put in here, the previous one, remember, it's not only for children. This is something which can be taken up also in higher classes. I would just like to leave this with a thought. Can you find some kind of arithmetic progression here, which is taught in class 10th? So people who know, because I know everybody would have taught, done mathematics till class 10, if you can find arithmetic progression in these patterns, all right? So it is not something which is only restricted to primary classes. They can also be developed for older students. Okay, so going on to the next one, what does this make you think? What is the first thing that you think about it when you see this picture? Square number. Perfect. Lovely answer. This is why. And I'll tell you why this is important. I think students start learning about exponents, that is squares and cubes, yes, like even square roots. All these things are taught in middle school, 7th and 8th. What they do not realize, it happens that the square numbers and thing, it is related to the area. All right, because the number when multiplied itself, if it were to be represented physically, it would look like a square. It's the same thing that if I were to draw a physical representation of the number 8, it would look like a cube, 2 cube, or 1 cube would be 1. We've all seen the sugar cubes and all those things. So here it is important to do so that children don't think that these are separate. People pigeonhole mathematics into, okay, this is trigonometry, this is arithmetic, this is this. No, they all come together to form a beautiful thing, and we use them interchangeably. Like this might look like mensuration, that we are talking about area of square, but actually it means the square of a number. All right. Now you tell me, what all do you see in this figure? Just write down one word, whatever you are able to see. Put as many numbers, okay, shapes. What kind of shapes? I would like the name of the shapes. Okay, 2D shapes. Can you specify the shapes, please? Triangles, okay. Any particular kind of triangles? Circles, triangle, circle, all right. I'm just waiting for a few things. All right. Equilateral triangle. I like that. Great answer. Okay, now have a look. The geometry behind the mathematics, the geometrical conversation. How do you like that? If you take out the color, that painting becomes pure geometry. Can you identify putting them together, and do you see that what all things are there? Can I have some, how many people have enjoyed this? See, I can't see your face.
Shall we have some teachers, show up? Yeah. Sarita ma'am wants to speak. Shall we?
Yeah, sure.
Okay. Sarita ma'am, please unmute yourself. There's so many teachers. Yeah. I think, Sarita ma'am, would you like to speak?
Maybe
Yeah.
the voice is not coming through or anything. That's okay. It's just that what I usually do, ask people to put, if they like something, thumbs up or smileys, because it's great to have in class,
Feedback.
as all of you being teachers, you want to, see those children's aha moments or them enjoying. But because of this situation, it has to be like this. So at least that gives me a feedback that whether, you people are liking it. Anyway, so where you see that beautiful art and pure geometry, there's hardly any difference. And we are going to take that forward. This is a Dutch painter, Piet Mondrian. I'll tell you something about him. He's a Dutch painter and theoretician who's regarded one of, the most important painters of 20th century, abstract painters. And look at this, that his paintings were mainly made of squares and rectangles. Not only that, I think out here all the teachers are aware of the primary colors. Can somebody just write down, tell me what are the primary colors? Anybody who would like to take a chance?
Just waiting for answers.
There, I've got the answer, and the absolute correct answer, red, blue, and yellow. Exactly. All the colors come from there. And white, of course, means absence of any color, and black is amalgamation of colors. So you can just Google search Pete Mondrian, and you'll see he used only these five. The white were the blank spaces, and black usually were the border. Rest, all of them were, primary colors. And through this, making it very basic, very primary colors, it became, he expected that it would be again a common global culture. Now, this kind of a thing, remember what I told you about accessibility. When you look at this painting, and let me tell you, his paintings, sell for millions of dollars, and these are usually used as, you will find, mosaics or murals or these kind at, big, huge halls and hallways, railway stations. I mean, those would be prints, of course. Um, do you find that this is something you could give it a try? That you would like to try doing this, making this one? Do you feel that way? This is something our children can try to make? Anybody to answer that?
Yes. Irene ma'am says yes.
Yeah. Okay. So that is what I mean by accessibility. Sometimes art is beautiful. Like when you hear classical music, or, say you hear some beautiful cello or piano or something, you love it. But, you kind of think, oh, wow, lovely. But you don't think of doing it yourself. You feel that, that's beyond my capability. I mean, I have to learn. But when you look at something like this, you say, oh, I can try this. And that's where it begins. So you can have a look at this. Now, see, these are kind of worksheets. Like if you see this one, which is there on the screen, it's based on Mondrian painting. I mean, Mondrian style painting, I would say. And it talks about area and perimeter. Do you think it would be an interesting worksheet for children to do? Would they enjoy doing it? We
Yes,
have
on
another
Facebook,
one.
we are getting a lot of answers saying yes, yes.
Yeah.
Unfortunately, they are not able to, speak, and that
Yes.
is
Yeah,
something that is.
I know. It's the what to do, the sign of times, all right. That, yeah.
I
Okay.
think Jyotsna ma'am
Jyotsna
says
ma'am
she'd be
says that
doing
she'll
with
be
class
doing
5.
it
Yeah.
with grade 5, and these are all available, these kind of things over the net. I've taken it from there, so you can. And let me show you the next one. You get, best thing is you get blank ones also, like this. Okay. So you can kind of make any question. Like I made up this simple question. I said, because, I mean, I thought, why not allow children creativity? Why just only primary colors? So I made the question, choose any 3 colors of your own choice. Color the shapes which are equal in shape and size. In higher classes, I would use the word congruent. Okay. In the same color. All right, so it is recognition of shapes, size, and children can come up with their own 3 colors. And later, maybe you can use it, have an exhibition or put it around the class. Or, in fact, if they do it on graph paper, they can even count again area and perimeter, total percentage, whatever. I mean, it is for the teacher to, take it beyond, I mean, whatever level he or she would like to. Do you think this is something doable? Because that's very important. whether, again, as I said, that what are these resources accessible for you? Are you, will you be able to do it? Because just showing you something which is, you know, up in the air and has no practical value is a wastage of your time. So I see here, Irene ma'am says that it's absolutely doable. I'm so glad about that. And you will find loads of them. This was just a very simple one I picked up. You'll find loads of them. You can ask students to,
On
you know,
Facebook, shall I just share some thoughts on Facebook that are running?
I would
Uh,
love to
yes.
have a look because, you know, I mean,
Yeah, so I'll just read them out for you.
yeah,
So teachers are saying we can do it on graph paper also. Children would love
yes,
to color, and
absolutely.
very much doable, man, is what
Okay,
Sapna Iyer is saying.
that's great. In fact, you can even ask children. I mean, I'm sure that parents would help them with the younger ones. They do that. They can even download these kind of blank Mondrian. You just have to type in blank Mondrian worksheet. Okay, and they will get all these blank ones, and they can, you know, make their own things. They can count how many shapes and all. It's, you know, it gives immense possibilities. Okay, moving on now. Tell me what you see in this picture. So right now, just in the previous one, we were dealing with squares and rectangles. What do you see out here? Quadrant, lovely. Triangle. So can we say that this is a combination of figures? So now we have moved a bit ahead from only squares. Yes, cone, absolutely. I'm so glad people, you know, got that sphere, cone. Yes, you can see an art combination of figures. And tell me again, is it something you feel that you personally could try doing it? Does it seem accessible to you? Do you think this will not kind of, children will think that, oh, this is too much, okay? Or they will be interested in making something like this? Yeah, I have another one for you, which is one of my personal favorites. How about this one? I love the colors. You know, you could kind of give an instruction saying that I would like you to make some kind of a figure which should have squares, rectangle, circle, and triangle. And so here you are talking shapes, but you can kind of letting the child creatively arrange it. All right, they will do the shapes, but the arrangement, which colors, what all those things would be the child's ownership of it. And that, I think, gives a major kind of boost to a child's self-esteem and learning and interest. I hope some of you go and try it. That would be fantastic. Okay. Okay, now I have a question. So everybody ready? This is a question for you all. You can see a 4x4 grid out here. There are some polygons hidden here. Can you find them? Uh-huh. Squares. Yeah, squares are definitely there. Oh, wow, wow. These are proper maths teachers. The answers are coming. Okay, let me show you. How do you like that? Can you find some more? Can you find a pentagon? Yes, rhombus. How about a
Trapezium.
pentagon? Trapezium. Yeah, right. Do you think this is something, again, children would enjoy? Yeah, to recognize figures and color them accordingly. Now, also, I mean, suppose when you are teaching them area and stuff, have a look at these four figures. Tell me, like, so there are red, yellow, blue, and, well, greenish. I wouldn't call that green, but anyway, these four figures there. What is the area of each one of them? You don't have to use the formula, just figure out. Shrikant, if anybody would like to unmute themselves and give the answer, I'm also fine with that.
So yeah, Nirmala ma'am wants to unmute and
Yes,
answer.
yeah, please.
There you go. Ma'am, please unmute yourself. Nirmala ma'am.
Blue as well as the red is the same, and the
Okay.
yellow and the green is the same.
Um, you mean to say blue and red?
Red
And
are same.
yellow and green. Ah, I've got the answer again. Same area for all of them. And actually, when you put together, you were right, Nirmala ma'am, half right, but exactly as the answers are coming up, that they are all the same. Now let's see how does that work. All right, you can see that this half can be put here, it becomes a square. This half can be brought here and this becomes a square. This can come here and this can come here and it becomes a square. So do you see, you don't have to know all kinds of formula for this. It is just that mathematical thing, how to move around figures and shapes and put it. It's almost like doing a jigsaw puzzle. You could ask that, well, if the first one is a square, can you make the others into a square also? Yes, exactly. You can count small triangles. So do you see what all possibilities it offers you as teachers to teach them whole lot of things, not just counting, not just thing. It's just that, yeah, we have to slightly get out of our usual textbook thing and think about it. But let me assure you that once you start doing it, I think, you yourself will get so interested that you yourself will feel like spending a lot of time. And in fact, I was just thinking out here, see, just talking to you people, it suddenly came to my mind that if we bring this yellow here and this blue here and fill up this, it would be 4 squares in a row. It would be a kind of a diagonal thing. Can you figure that out? I mean, suddenly came to my mind.
Ishita ma'am, I think your screen is stuck. Hello?
Shape, what kind of so all sometimes, our questions, what we call in mathematics parlance, are closed questions. We say, okay, what is this, yes or no, or the answer is right or wrong. There are no two ways. We don't seem to be able to promote discussion, but only if we change our questions a bit. Out here, you see, this is a 10 by 10 grid graph paper, and I say, okay, I want a figure whose area is 48 square units. Create a figure and justify your answer. This child makes it, okay, and has to show that why is it 48? And it could be any figure, all right? You're not restricting it to like you have to make a square or you have to make a rectangle, triangle, or a circle. No, nothing. All right, you just say make a figure. So my first question to you as teachers would be, see why this question, as I said, is actually a hot level thinking question. If you think about it, can you make a square out of this? Is it possible? My area is given 48 square units. Can I have a square? Are you sure? Okay, what would be the sides of the square?
There's a teacher who says no. On Facebook, quite a few people are saying no. You can't make a square out of it.
Absolutely. And they are totally correct. It cannot be a square because 48 is not a perfect square. Think of the square numbers. We have 5 into 5 is 25, 6 into 6 is 36, and the next one, 7 into 7 is 49. All right. So therefore, we cannot make a square. Whatever figure we make, yeah, 49, right, Tanya ma'am? But it cannot be, nearest is 49. We can't have a square of 48. But what can we have? We can have loads and loads of rectangles. Can you give me some rectangles, examples of what all kind of rectangles we have? 6 into 8, perfect. Anything else? Is that the only one possible? 12 into 4, lovely. More. 50, no. We are looking for 48. The area is on 16 into 3, yeah. So can you see that how people will have that different kind of, you've asked children, they will come up with different numbers. And what, do you see some underlying mathematical fact happening here as you are teaching this? Yes, 48 into 1 is a lovely answer. When you write all these numbers that you're writing on screen, what exactly are you doing? What is the mathematical concept that you are using to get all these dimensions? Think. Exactly. Tanya ma'am's on a roll out here.
Factorization.
Factors and multiples, multiplication. So do you see what all things, it's not just about area, which is mensuration. It is also about factors and multiple. It was about exponents, squares. Like, why can't we have a square 48? Because it is not a perfect square. So you see a simple question. And the next important question, because this is something that so many students get confused about, area and perimeter. Now, area, everybody's will be equal because they'll be using factors of 48. All right. But as they draw their own figures, where it's 12 into 4 or 16 into 3, anything like that, their perimeters would be different. And so you can ask them that find the area is given. You have to justify how it is 48. Find the perimeter. What do you see about the perimeters? You can ask the whole class. They can do it, individually, pairwise, whatever. That depends on you as teachers. So these kind of question gives you a lot of depth. Also, as children are making their own things, the knowledge, the experience is deeper. It's experiential because they are doing it themselves. Okay, what are these? First, tell me, do you recognize these? Anybody who recognizes what these are? They're
Looking
seen
for
all
answers.
over and multicolored.
Ludo. Someone says Ludo.
No, not exactly.
Sticky
Sticky notes. Yes, the correct answer is sticky notes. See, isn't it a lovely design made using sticky notes? Yes, post-its. They are also called post-its. Now look at the mathematics behind it. Okay, I'm going to put it there. Firstly, it's a 9 by 9 grid, so the area that is 81. And here are all the things. You've got fractions of, because it's 9 by 9, so that is 81. So you've got area, perimeter, the array, and then you have the various fractions of each color. Doable? Yes or no? Oh, I see a smiley. That was great seeing that smiley. Yes, I'm so glad. And do you think, is this doable? That they don't have to make just this one, they make their own designs and given the details, all right? What are the fractions, which color, instead of out here, there are 4 colors, you can give them an option of making 5 colors or 2 colors, 3 colors, okay, and they have to give. We can, in fact, actually take it beyond this. This was about fraction. So let's look at this. This is something called FDP. It's very similar to what you see, but you don't need post-its. You can do it on graph. So as you can see, here's a 10 by 10 grid. And this particular question says that use 8 colors, make your own designs, and then create an FDP. So what is FDP? FDP is nothing but this table. So you have like 8 colors, so there'll be 8 rows, then 1, 2, 3, 4, 6, 7, 8. What is the fraction of the first color, supposing it's blue? What is the fraction? Then you have decimal, and then you have percentage. Would you think that would be a very, very good learning experience for students, say class 4, 5? Because it takes up all of them simultaneously and makes them understand the connection. Because, you know, one mistake which I find a whole lot of people do, and even adults I find doing sometimes, that when you talk about, oh, you know, 100%, a lot of people think of it as 100 times. Now, there's a huge difference between 100% and 100 times. 100% is one whole. 100 times is multiplying it by 100. So when they are doing these kind of things and making columns, it becomes quite clear to them that the percent is not that many times, it is the part of the whole, you know, like as in out of hundreds. So this is something you could give it a try, and I would really like to know whether your students enjoy doing these kind of things. Here, okay, tell me about the first one. There are 4 colors, and I want the fraction of each color, a percentage of each color. The first one is a 3 by 3 grid. Anybody coming up?
Looking for answers.
You have to give them a bit of time because...
Yeah, exactly.
Yeah.
I think Nirmala ma'am has shown up a hand. Shall I unmute her?
Yeah, sure.
Nirmala ma'am, again, please unmute yourself. And
Yeah, one color is 75%. That is
one color is 75%. Are you sure, ma'am?
yellow.
Yeah.
Yellow. You want to remove the colors, or you want the colors as a whole?
Like how much, what percentage is yellow out of the whole grid?
Yellow out of the whole grid.
Yeah. The whole grid is 3 by 3. So that's 9.
Okay, you are talking about the whole grid. Okay.
Yeah.
It will be 25%.
Portion is 1.5 grids.
Yeah, it is 25%.
So that is your 1.5 over 9.
Yeah.
Correct? Are you sure it's 25%? That's 15 by 90. I would say 1/6.
1/6.
Yeah. There I can see 1.5 by 9. It is 1/6. Yeah, that would be 16.7. All right, nearly. Because 16 into 6 is 96. Therefore, 1/6 is the entire grid. That's the absolute correct way of writing it. Vidya ma'am has given the, I mean, I can see only the chat box. I'm sure, Shrikant, you might be seeing a lot.
Yeah, lot. So shall I read out?
It is 16.7% nearly. 1/6, if you put it that way, you know, would be correct, or 16.7%. And anybody wants to try the next one? Actually, you know, I mean, it's not necessary. What I said, do you think these things are doable in class? And to take it a step forward from this, once they have, you know, found out from whatever designs that you give them, can you say that, okay, now draw any design that you wish, which covers, say, 64% of the area, which means in a 10 by 10 grid, 64 squares can be colored. All right. or you can say 50% of it or 40% of it. Do you think these kind of questions can be given to children?
Yes.
I can't see the answers here. Maybe Shrikant can
Yes.
probably.
I'm seeing the answers, ma'am, and they say yes.
Yeah.
Some people reckon it could be also done for the higher grades.
Yeah, okay. I'm just because I think percentage, fraction, they can use instead of percentage, they can do fraction. All
Yes.
right. That color, say 3/4 of it, or maybe like in this case, because it's 9, I could say make a design which would cover 1/3 portion of it. Okay, yes, like Tanya ma'am out says, with a 10 by 10 grid, we can give for primary class. Yeah, obviously. I mean, I'm not saying that like the first one is 3 by 3 grid, the second one is 4 by 4. So you can use anything. 10 by 10 grid would make it so much easier. All right, so that depends on which grade you are teaching, what kind of questions you wish to give. All I was asking about the concept of whether this is applicable. Yes, move from simple to complex. Exactly. All right. I'll just take a second and thank you all the people who are here. You people are so participative. And, with seeing, though I can't see you people with the answers coming in regularly, I know you are paying attention, and that really is very motivating for you. Thank you so much, people. So we'll move on. What do you think of this? Is it creative?
Uh, wow.
I can see a wow here. Fraction art, yes. Okay, can you tell me something, a concept you can use this for teaching? Can you think of a concept that you can use for teaching using this? Fraction, yes. Yes, for 1/4, you are on the right track, Tanya ma'am. Can you go a bit more? Just like you said, 1/4 are yellow to make a whole. All right. Can you take it a bit deeper? As you said, simple to complex. Equivalent, yes, good. 1 by 12 needs 12. How about division of a fraction by fraction? Like if you take 2/1/8, so 1 by 4 divided by 1 by 8, you get 2 pieces of 1 by 8. 1 by 4, if you divide by 1 by 12, you get 3 pieces of 1 by 12. It's a total physical demonstration of division of fractions. All right. So you can, and these kind of things, most, yes, 2 1 by 8 makes 4. So you can use it as division or even multiplication, like 1 by 8 into 2 makes 1 by 4, or 1 by 4 divided by 1 by 2 gives you 1 by 8 gives you 2. So these are, you see, deep concepts which are there, and these things are available in school. These are those sponge, those material which are usually available in school, but even if they are not, you can make it out of paper. Doesn't even have to be colored paper, though of course colored papers make them look attractive. So you can cut it in various kind of shapes, and not necessarily that they have to be circular. You can make it out of square shapes also. In fact, that might be easier, but this, looks great when you make something out of it. I don't have, because, there's a paucity of time. I could have shown you such beautiful fraction art designs that children have made, not just, teachers. Children have made beautiful ones. And then, okay, the last question here for this question: what is the total of this? What is the total of this fish?
Looking for
Haha.
answers. I think they're taking time. Yes, we're getting the answer.
2 1/4 correct. There, I said Tanya ma'am is on a roll. So there are 2 circles, full circles. You see, yellows make one circle and there is a quadrant left. So the three purples and one yellow makes the second circle and the red portion makes 1/4. So it is 2 and 1/4. Okay. All right. So now moving on. Have a look at this. This I've used, I mean, for some of you, if you want to integrate in your lesson, kind of lesson plan, how you can write it. Okay, so in class 4th and 5th, we are not talking about area of circle, but they learn to draw circle, right? Using compass, ruler compass and all that. So here's the figure. You can see how many circles there are, all right? In fact, okay, let me ask you, given the diameter of the biggest circle, which is C1, can you figure out the sizes of the other circles, the diameters of the other circles? Is that possible? Yeah. So you can have a look at this lesson plan. I have made it for class 4. So what are the learning objectives, the things that you write to construct different circles of different sizes, calculate the diameters and radii from the given diameter. So, it could be either way. You could give the diameter or radius of one of the small circles and they have to kind of work out the bigger ones, or you give the bigger one and they divide and find out the smaller ones. So I've left that for you. And of course, construction. The prerequisite knowledge is what? The relationship between diameter and radius, that when you find the diameter, the radius would be half of that. The concept of division, actually in this case, you could write division and multiplication, because if you are giving the inner diameter or radius, then they multiply, and if you give the bigger one, then they divide. And I've given suggested approach. Please see the word suggested, because every teacher has their own approach, own method. So this is my suggestion. You are most welcome to, try it out the way you would like. Okay. So again, as I ask the questions, do you feel this is something doable? And after that, they can color their own designs. Will they enjoy doing it? Yes,
ma'am.
Jyotika ma'am, the diameter C1 would be given. Yeah. Okay. All right. How's this? This I have not given an approach, but this I found so lovely. Why, I'll show you. Just look at this. In older classes, I would probably ask them, you can maybe do it only with squares also. And then I would ask them to find out the ratios of the areas for junior classes, whereas in higher classes, I would ask them to find out the ratios between the squares and the areas of the circles and, build it up. Okay, and after that, of course, they can color it and project it in any. Just imagine, like, I'm sure each school has their maths day and maths exhibitions and all these kind of things. So if you put up, suppose one class does on triangles, somebody does on circles, somebody on squares, various these kind of things, and you display it, I think that would also be, yeah, the area of the shaded portions can be done, but that would be for higher classes, not for primary. But what I'm showing, that these kind of things give you major space for creating very interesting questions. Now, I'll slightly move away from paintings, which I did not want to, were one of my favorite things. So I'm going to go to a question. Now, have a look at this question. I would first like you to read it. Now, This is something that I made, and I'm sure by now you teachers, because let me admit right now, right here, that I'm pretty tech challenged. Okay, so if I can do something, anybody can. Now, this question may be for a class 4 or 5, because I think almost all of you will agree that when it comes to word problems, our children find it very difficult. The same question you ask them directly, add or subtract, they can do it. You put it in a word problem, they get stuck. So I made it visual. Now, there are 3 girls. Please note the hairstyles because that's where the difference lies. From the question, can you tell me the total weight? You can put it in the chat box. Okay, no, the total weight is 164, correct? So one girl has got off. All right, you can see the one with the short hair has got off. So what is the weight now after one girl has got off? It is 104, which means what is the weight of this girl? Right? Sarita ma'am has already finished. Okay. So therefore, once you found her weight, the second girl also gets off. So there's only one girl left. Okay. And what weight is it showing now on the screen? Okay. So basically, you can figure it out. The answer has already come. What are the weights? Now you tell me, can you do this as a role play in class? Somebody makes a cardboard, that weighing machine kind of thing, and so because you can't, like, the weight obviously wouldn't change, somebody can hold up a placard and say, okay, now it is 164, now it is one person gets off, and now, do you think children would enjoy it? So what I mean to say is, you can take any these kind of questions and just make a tiny role play of it. You don't have to have major stuff, anything, no props and all that, really, not too many. And you can just, like, that weighing machine can be just made out of a chart paper or cardboard. And it is, sometimes what you can do, maybe with slightly older kids, and they are so good at all these animations and stuff, you can give as a group project, maybe one question each, or they can choose their question, ask them to make it visual, whether by acting out, or if they can, I mean, now of course physical acting, I'm sure one day we will be definitely out of this situation, but maybe if they could work as a project and make it visual like this. And imagine if people do it, you can ask maybe the older children to do it for you. Imagine the kind of resources you teachers would have. That's one good thought for us. All right, so ultimately I have this one thing to say to all of you, that we are constantly, looking for intelligence, teachers are, we have these words, are nahi aata, nalayak bacha, and all these kind of things. But more than that, if we kind of look, for interest, okay, how to make it interesting, how to get children interested in what we are teaching. Nothing very hi-fi. See, I think whatever we did here today, it wasn't anything earth-shaking. Very simple things, very doable things. But I can just hope that you people enjoyed it. And if you did, I'm sure your children would too. So that is something we need to keep in mind. And with that, I would say thank you. And if you want to look for certain resources, you can, these are certain further explorations. If you're looking for the kind of pictures and stuff that I used, these are here. Shrikant, anything?
Yes, ma'am. So thank you so much, and we are open for questions. However, lot of thoughts, lot of uh, regards for the session. In fact, there are many teachers who are saying, Thank you so much. Interesting ways to incorporate art into teaching mathematics. And
Thank you so much. I can see
on
it in the chat box also.
yes, but a lot more thoughts on Facebook, obviously. And now we are open for questions in case there are teachers who want to ask ma'am questions.
Sure.
Uh, we are open for questions right now. So most of them just praising the session. They just loved it.
You could
They're
read
saying
out some of the questions. I'll try and answer. I am not being able to thank each one of you personally, but I can see on the chat box your compliments. I'm so grateful and thank you so much. It's like, these keep me motivated. And my biggest thank you would be if you even use some of these ideas in class and they are successful for you, I would really feel blessed. So do go ahead, try out your new ideas. And I'm sure, when you do them and when children love it, you will feel yourself so satisfied.
exactly. So someone is saying awaiting for another session. Very informative, ma'am. Yes, we have a session day after tomorrow, same time, obviously 4:30 to 5:30 for the teachers of higher classes, which is classes 6 to 8. So I'm sure all of you
Six to
again
even 10th can do.
6 to 10. Yes.
Yeah.
So I hope all the teachers would also attend that session. Uh, I'm just trying to search for questions. However, there's one question that Hardip ma'am asked. She says, "Ma'am, can you please share more ideas?" I mean, that's very abstract, the number of ideas. But if you can give any specific topic, I'm sure ma'am would be able to share her thoughts. Uh, Lata ma'am says, can we have a session for 1 and 2? We can always explore that, Lata ma'am. Thank you so much for that idea. And
Shrikant, can you hear me?
yes, ma'am. Now I can. I think you're stuck a little bit
Oh,
for
maybe for
a
a
few
second or so.
seconds.
I
Yeah, for a
missed
few.
that question. You said Harpreet Pam or somebody had asked about, sorry, sharing.
Hello, ma'am. I think again you're stuck. Yes, yes. You're
No,
asking
I
something.
can hear you.
Yes, ma'am.
Yeah.
So, ma'am was asking if you can share 1 or 2 examples for primary classes, which is classes 1 and 2 for the foundation.
Oh, okay. So in that case, I think we can have various color blocks. One of the beautiful things where you can do, you can just Google search for theory of colors, where you have these colors, how they mix each other. So one drop of blue, so that is one circle, and maybe two drops of red make a violet. So those are very colorful, and they're also very nice way of teaching children how to count. And otherwise also, you can Google search art integration for primary classes. You can, and one lovely place where you can check up, in fact, that is Pinterest. I'm sure a lot of you have heard of Pinterest. Maybe you have an account there also.
Yeah, I'm sure many people have heard of
I'll
Pinterest.
just I'll just write it down. That has lovely stuff.
Ma'am, can you give us ideas for teaching measurements, especially in virtual classroom? That's one last question that Chitra ma'am has asked.
Measurements, yeah, sure. What you can do is, again, you can take various strips. In fact, I saw a lovely question, I think, on Twitter. Okay, they had taken colored strips of paper. And then, like, what is this now for very small children? I mean, classes 1 and 2, especially class 1, they don't go by formal measurement, whether it is a finger span or hand span, that is the units that they use. So you take a strip of paper, a colored strip of paper. Okay, how much would it be for it to make a band around your hand? Okay, how much for a ring? Or the length of your finger. So they cut those strips and write their names on it. Yeah, non-standard units, Lata ma'am. So, they make these kind of, you could say, jewelry or something. Okay, this much is my hand. So they cut that much of strip. And here, you can make it like now they are home. So maybe their parents can help, because, when you have to put a strip of a tape around them, a colored thing. So you need a bit of help. In class, they can do it as, projects, like, not project, a group, like 2 3 children, so they can help each other, and they can put up a thing that these are our bands for each one of us, and then they can design the exactly, measure various parts. Yesterday again I saw a beautiful thing, maybe that would be slightly weight. Maybe you can give them circular papers and cut this thing, where they make these cheerleader skirts. Okay, so that is, it's nothing but concentric circle. I mean, you take a piece of round circle paper and cut out a round hole. The smaller one is the waist part, and the bottom part is the flared out. So it looks like a skirt. And then they put a waistband. I mean, just draw it. Okay, which one is the bigger band? They can put, strips to make design. So how much are the strips equal? So all these kind of things can be done, Lata ma'am.
Yes, thank you so much, ma'am. I think it's already time for us. Due to the paucity of time, we might not be able to take more questions. But however, I'm sure all the teachers would attend ma'am session again day after tomorrow, same time and same place. But overwhelming response, ma'am. I think we should see Facebook for that also. But then, thank you so much for a wonderful session. Teachers loved it.
Thank you.
And on behalf of
And
Poland,
thanks a lot to all the participants, whether here or on Facebook. It's, really, I'm overwhelmed. Thank you so much.
thank you so much, ma'am. And to all the teachers, you'll be getting your certificates. A lot of questions about certificates. You will be getting your certificates. So thank you so much for your participation. And also to all the teachers, uh, we thank you for your overwhelming suggestions and also, uh, the kind of interest you've shown in this webinar, in the first art integration webinar for mathematics. Uh, and teachers, one request, please be safe at home. And also please, uh, you know, take care of everyone around you. We thank you so much for being here. Wish you all a safe time ahead. Thank you so much.
Thank you all. Bye bye. Take care. Stay safe. Stay healthy. Stay happy.
Thank you. Thank you so much, ma'am.